Hello, everyone. I'm Alicia Knighton, and I'm a senior implementation engineer at Honeycomb. At Honeycomb, we take you through your observability needs, whether it's SLOs to tracing. We open up the whole black box for you. Okay, guys, let's talk about what we're going to discuss today. So we're going to discuss what's observability, what does it mean to a company and an individual, how observability improves processes. So just to let you know, customers are the reason for the season. At the end of the day, if their issues are not resolved, we can potentially lose them. And if we lose them, we lose money. And who wants that to happen? So let's jump in. Let's talk about today's challenges. Software is built over distributed systems, which means simply it's complex. And then there's the infrastructure component interactions. There are many potential combinations of things that go wrong, and sometimes they sympathetically reinforce each other. This can lead to new types of challenges that we know nothing about. Also, the whole theory behind testing in non-production versus production. As we know, production is simply not non-production. So no matter how many times you have PII data that you're flowing to that's exactly the same that production has, it does not simply show what's going on at that time. And then there's a lack of knowledge across teams. So quite frankly, if you're working on, let's just say, the billing service, then you're going to know about the billing service. You may not know about the other intricate pieces that work with that service. And why should you? It's not your job. So with all that being said, in walks observability. So what is observability? Observability is about being able to ask arbitrary questions about your environment without having to know ahead of time what you want to ask. Observability focuses on the development of the applications and the rich instrumentation you need, not to poll and monitor for like thresholds or define health checks, but to actually ask arbitrary questions about how the software itself works. It's to understand the answers that do not come ready to order. And what I mean by ready to order, monitoring itself is known for problems that don't address the growing number of new issues that arise. You need to be able to ask those questions that you had not participated or anticipated in the first place. So what's the goal of observability? The goal of observability is to empower your team to be able to address issues before they impact customers, safely instrument and implement optimizations, promote knowledge transfer within and across team boundaries, better manage business risk, and support stakeholders. Like I said before, customers are the reason for the season. At the end of the day, if their issue is not resolved, we can potentially lose them. Furthermore, engineers are what keep the flowers in the season blossoming. So if they cannot water the plants, then there's no garden. So let's talk about benefiting infrastructure teams. So doing my job does not require me to wake up at 3 a.m., but it does require me to do a little bit of collaboration. We should be able to look at something and then figure out as a team what it is, despite what the actual alerting tools may say. So what do I mean by that? I might not exactly know what I'm looking for, but I want to be able to start somewhere. I don't want to be in a situation where I'm looking at all the greens in a dashboard and the customer is still telling me I have a problem. I want to be able to say, okay, how do I identify this customer? After I identify this customer, let's go through all of these intricate systems to see where the bottleneck may arise. So as a team, we have to do a little bit of what's called a core analysis loop. So the core analysis loop allows us to ask questions about our systems, dig in to investigate. It allows you to refine your hypothesis and fine-tune your questions. So in a nutshell, first we must identify something that's interesting. So this may be increased latency, for example, and formulate a hypothesis about why that may be happening. Maybe this is happening for a particular customer or an AWS instance that's experiencing just high latency on its own. Then we test our hypothesis by breaking it down on that field to compare the relative performance of the various different groups. So you may have a baseline, and that baseline may be your normalcy, and we'll be comparing against that. And then, having done that, we look to see whether that has helped us refine or reduce our search space for that question. Does one customer performance stand out on their list? Can we control some of these bottlenecks? Can we zoom in? Should we even keep investigating on this? Observability is not just about scrolling through dashboards or grepping through logs. It means that mainly we're being very active on asking questions and being able to iterate over them. It means being able to follow a thread of investigation from a high-level graph through to the end without having to do many tool jumps in between. So what does this look like? So there are many tools that roam in the observability space, but they all have key components that formulate the same result. So let's talk about distributed tracing. So this is an example of what's called a waterfall trace. So a trace tells a story of a complete unit of work within the system. Each part of that story is told by a span. So if in your system, you may have connected to a database, then that portion of it would be a span. And then spans are simply events that include metadata like the service name that it belongs to, the duration, so how long it took. And if we go back to the database example, then it may also include things like the database name and the query language. So in this example that you see here, the user hits the ticketing service, and we can see that all the services that are involved in that. And then if you want to think about it in more layman's terms, you can think about how a user hits a login web page. So to get to that web page, there may be a proxy that calls out some type of authorization service to ensure that it's X person. And then in all of that, that result may return to the client. And all of that is essentially a unit of work. We can also look at our build events in terms of tracing. So here on the screen, I have an example showing a build that was ran in Circle CI. So it goes through running Go tests and setting up JavaScript dependencies, and then it triggers the JS build and what we've identified as the deploy test in parallel after those dependencies are configured. So placing a trace around the build event gives me access to how long the entire build ran and the components within each of those processes. We can then use that trace to drive minimizing deploy times. And even if it fails, we can pinpoint the culprit. In some cases, it may not be your build. What's in your build? It may just be something happening with what you're using, like Circle CI or Jenkins. And putting observability around those things allows you to make educated responses to those scenarios, not educated guesses. So I want to provide a quick example. So the latency issue. Everybody knows about latency and how that can be a problem. If we're moving too slow, then customers may go. So let's run through a quick example on determining an issue in the system. So we'll look at asking the question, formulating and testing hypotheses, and drawing conclusions from it. So I have my application instrumented in Honeycomb, and I have been alerted via software that there's a latency issue of some sorts. So traditionally, I would go through and use logs and see if there's any support tickets with customers saying that this is an issue, but since I have this available tooling, I'm right in front of the problem. So I can just use the tooling to drive what's happening instead of being behind the situation and waiting on a support ticket, for example. So as you can see on my screen, for this particular example, I have, like I said before, selected honeycomb, and I have associated with a particular data set. This data set will have all of the metadata that I can possibly gather from the software auto-generating spans for me, plus the custom instrumentation for things that I could not get from auto instrumentation. So as a result, I've been tracking the application's duration, and I see this weird spike in here, and I want to dive in there. Note that when I hover over there to this spike, I also see a correlation with the overall performance. And what I'm noticing is that with this spike, automatically, I'm noticing the error rate associated with it. So without doing much of anything besides auto instrumenting and adding custom spans and things like that, I have literally uncovered that whatever's happening here with the latency is pretty much associated with the error rate there. And from there, I'm just going to I can use the run query feature to deep dive in. But here, this particular software that I'm using has a feature called Bubble Up. So I'm going to use that feature to further enhance my knowledge on what's happening here. So I'll deep dive in there. And so using this feature, just to click over to this tab, I have all of this metadata here. So I have things like the app build, the endpoints, the platform, all the status codes, there's ticket IDs, there's app user IDs, durations, and things like that. And all of those things are relative for me to understand what's going on with my system. And so I'll go back to this tab here, and I'll enhance it where the thing has gotten a little weird. And so from enhancement, from where it's gotten weird, I'm able to see what's called dimensions. So right now we're looking at a heat map. So we're looking at the highest densities where there's a higher concentration. And I'm seeing a lot of normalcy here. And then I'm seeing the spike, as I mentioned before. And by deep diving into the spike, I'm able to then see what the baseline is. So baseline is in blue, and that's what's happening during a normal situation, right? But then we have this little peak here, and that's in yellow. And literally, it's pointing to the endpoint. And furthermore, I'm actually able to quickly see what the error is without doing anything. And I'm noticing I have high cardinality data is what we call it. And high cardinality data just means that I'm able to use something to identify a particular thing. And in this case, I have had high cardinality data around my user ID. And so I know that this is coming from this particular user. Now, with all of that being said, I also have all of these things as well. And so if I want to, I can click on this particular column and I can drive the next question. And so my next question would be, okay, well, let's group this by user IDs. Maybe I want to know what other users are experiencing this, or if they are experiencing this, is it relative to this particular user? Meaning this user is having high peaks, or is everyone else having high peaks? Or what's the error rate from everyone else, and things like that. So I can quickly deep dive in and I can drive my fields to do so. The other cool portion in being able to observe the thing really quickly is using this function. I can click in here and it's going to take me directly to the trace. So I have step into the trace where the issue is uncovered, what is in the trace. So I can see what's happening there. And there's a loop that's causing it to expire. I can alert my team and I can follow up with this customer on what's happening. The cool thing is I can see everything. So there's fields that allow me to see what's happening. So what's the name, what services are involved, what status codes are being spilled out. If I have high cardinality data, so the user ID and things of that nature. We're able to then explore if this latency is a single point of failure for a particular customer or multiple customers. We can then say, okay, well, based on what we've discovered and our hypothesis and our conclusive findings, we can then create a user story to then revamp this code. We're now driven by our knowledge that we've gained by exploring what's coming out of our production systems, as opposed to the knowledge gained based on what's coming out of our non-production systems. And that is great in itself because we can take care of our customers real time. And as we said before, customers run the show. So with observability, it allows you to breathe and believe in the questions that you're asking and to formulate answers from that. I would like to thank you for joining, and I hope you enjoyed this presentation. Have a wonderful day.